Hello everyone. Today we will consider a very important topic for surveyor. Because construction layout puts the surveyor in the unique role of translating the project visualized by the designer and shown on the architectural or civil drawings for the contractor who will build this project. And this role requires the surveyor to be able to read and interpret the drawings and make the necessary computations to locate the project correctly on its site and to accurately communicate those interpretations to the contractor. So construction surveyor must be able to work with metric and English units and to convert between them. In interpreting construction drawing, the surveyor to prefer use English units of feet, inches, and fractional inches. And civil engineers who produce drawings for site improvements, parking lots, and entrance roads prefer to work in survey feet and tenths and hundreds of foot. For example, angular measurements in the United States and Canada divide a complete revolution circle into 300 degrees. Each degree contains 60 minutes and each minute contains 60 seconds. Radians are also used to describe angular measures. There are 2 pi radians in one complete revolution, 360 degrees. 1 radian measures 180 degrees divided by pi. It's about 57 degrees. So you can see side drawings here by use degrees and feet. In this table, you can find the equivalencies for metric and English units and angular measures. For example, 1 foot equals 12 inches. 1 yard equals 3 foot. 1 rod equals 60 16 1/2 foot. One chain equals 66 foot. You already know that 1 kilometer equals 1,000 meters, 1 hectare equals 10,000 square meters, and 1 hectare equals 2.471 acres. And some conversations require intermediate steps, such as converting inches to feet before converting to metric. A construction layout may require conversions in either direction, from English to metric, from metric to English, etc. An example: convert 1 feet, 1.5 inches to the metric equivalent. First, convert the given length to decimal feet. You understand that 1.5 inches can be expressed as 1.5 inches. As a result, you can see 1.5 inches multiple to 1 feet divided by 12 inches, because 1 feet equals 12 inches. Yes? And all this will equals 0.127 feet. So answer: 10 feet and 1/2 inches equals 10.125 feet. Next, convert the result to metric. From table, you can find that 1 feet equals 0.3048 meter. It's exactly. And when you find 10.125 feet multiple to 0.3048 meter divided by 1 feet, all this equals 3.086 meters. So 10 feet and 1/2 inches equals 3.086 meter. Very easy. And you use table. Of course, you use this table to convert all these units. Also, the conversation may be worked in reverse. Yes? So to convert 3.086 meter to the English equivalent in feet and inches. So you can find the same that you have previously. Subtract the whole feet before converting the decimal feet to inches and fractional inches. So 10.125 feet minus 10 feet equals 0.125 feet. And then 0.125 feet multiple to 12 inches divide by 1 feet multiple 1.5 inches or 1.5 inches. So you have the answer. The next example, convert 1 square mile to square feet. 1 mile is equal to 5.280 feet. So you can see in table, yes, 1 mile equals 5,280 feet. So set up a conversion equation, remembering to square to conversion factor of feet per mile in order to cancel the units of square miles and obtain the answer in square feet. So it will 1 square miles multiplied by 5,280 feet divided by 1 miles. Of course, squared, and equals 27 millions 878,400 square feet. Convert 36 degrees and 46 minutes and 28 seconds to decimal degrees. First of all, the minutes you must convert to degrees, and of course seconds also must be converted to degrees. So what it means? 36 degrees plus 46 minutes equals multiple to 1 degree divided by 60 minutes plus 28 seconds multiple 1 minutes divided by 60 seconds multiple 1 degree divide 60 minutes. So you receive all units in degrees, and then you find 36.7744 degrees. Working the problem in reverse, convert 36.7744 degrees to degrees, minutes and seconds. So, first of all, you convert degrees to decimal remainder, so to minutes and to seconds. What it means? Degrees multiple to 60 minutes divided by 1 degree, and you receive 46.4640 minutes. And then from minutes you convert to seconds. So minutes multiple to 60 seconds divided by minutes and equals 27.84 seconds, round to 28 seconds. So answer 36.7744 degrees equals 36 degrees 46 seconds, minutes and 28 seconds. The next. What is the line and angles? Two-dimensional construction drawings. Plans use lines to represent physical elements, such as the edges of buildings or pavements, as well as abstract elements such as right-of-way lines, property boundaries, or building setback lines. So, what is line? Line is defined by 2 points, and a straight line forms the shortest distance between those points. Angle may be acute, 190 degrees, obtuse 190 degrees, right 90 degrees, or straight 180 degrees. The measure of the acute angle and obtuse angle on the same side of the intersection line add to exactly 180 degrees, forming a straight complementary angle. And two angles that add to form a 90 angle are called complementary angles. In the special case of perpendicular lines, all opposite angles formed by the intersection lines measures 90 degrees. On this slide you can see polygons. What is the polygons? This is a closed figure formed by 3 or more intersection lines. If the sides don't intersect each other, the closed figure is a simple polygon. In construction surveying, simple polygons may represent such things as the shape of buildings, the edges of concrete structures, or the boundaries of a building lot. A complex polygon has sides that cross each other and may represent such things as project control networks. When used alone, the term polygon is understood to refer to a simple polygon. Perimeter of any polygons is the sum of the lengths of all the sides. Perimeter and area relationships for four-sided figures that include parallel sides, parallelogram, such as squares, a rectangle, and trapezoids. You can see here. The angle inside a simple polygon are called interior angles. And interior angles, sums of interior angles, multiple the next. N minus 2 and all these multiple to 180 degrees. And what is the n? N is a number of sides. The sums of the exterior angles of a polygon is related to the number of sides. So it's a n plus 2. So here it's 6 multiple to 180. So what we should doing to find the interior angle of an arena. We know, we see that the figure has 8 sides. The sum of the interior angles should be by this formula 1080 degrees. So this will be an answer. Triangles. A polygon with exactly 3 sides. The triangle is central to many surveying computations and deserves special attention. The sum of the measures of the 3 interior angles of a triangle is what? Exactly 180 degrees. N is a Steeler's triangle, has 2 angles of equal measures and 2 sides. N equilateral triangle has 3 angles of equal measure and three sides of equal length. A right triangle, perhaps the most frequently used in construction surveying, has one angle equal to 90 degrees. And you know that the side opposite the 90 degrees angle is termed as hypotenuse, hypotenuse, and other two sides a height and base. Two triangles are termed congruent if three of their corresponding parts are equal. Two triangles are termed similar if two of their corresponding angles are equal, and the lengths of the side of similar triangles are proportional, so that the unknown lengths of corresponding side can be found by ratio and proportion. So two triangles are termed similar. Yes, similar if two their corresponding angles are equal. So the lengths of sides of similar triangles are proportional, so that the unknown lengths of corresponding sides can be found by ratio and proportion. Now we see an example given a pair of isosceles triangles with the base angles equal to 35 degrees if the height of the larger triangle is 15.27 feet. So we understand that two triangles are similar and the bases are parallel, so the base angles of the smaller triangle are also 35 degrees. The height of the smaller triangle can be found by the following ratio. So by this equation you can find a height of a small triangle. So we know all these units. So then solve this equation by cross multiplications. You find that height of a small triangle equals 10.20 feet. Remember trigonometry, and trigonometry is the study of triangles and the relationships between angles and side. The trigonometric functions can be defined for right triangles in terms of the angle A, B, and C, and the side opposite of those angles A, B, C. So these relationships are typically calculated and sinus angle A equals opposite side divided by hypotenuse. Cosinus of angle A, adjacent side divided by hypotenuse, and tangents A, opposite side divided by adjacent side. And law of sinus. By this formula you can find. Example. Surveyor needs to determine the distance across an 8-lane highway as shown in here. Points A and C on the near side of the highway are selected for convenience. Occupying point A, the surveyor side on point B on the far side and find the angle BAC. The distance from A to C can be measured. So moving to point C, on the near side of the highway, point A is sighted and the angle ACB is found. Knowing the length of the one side and two angle, we can calculate the angle B and find the unknown distance AB using the law of sinus. So you can see A we know, A unknown, B we can find by this formula. Yes, by 180 degrees minus this angle plus angle ACB. And then using equation of proportion of law of sinus, you can find side AB. So this distance is 289.99 feet. The next, law of cosinus. Remember, and this formula can be rearranged to take advantage of the known angles or side. In this table, you can see given angle or side, and if you require to find a distance, or you must find an angle, you can use this formula. And also in appendix 2 of this book you can find additional trigonometric identities. So example, a surveyor needs to know the distance between point C and B. In this sketch, A building obscures the view directly between the 2 points. Setting up at the end of the building at point A, the surveyor measures the two distances, AC and AB, and the interior angle A. What is the distance CB? So CB will be A, side AC will be B, and side AB is C. It will be easily. And the interior angle at A is 80 degrees, 30 minutes. So use this table and we must find the angle by these formulas. No. We know we must to find by this formula. Yes, by this formula. Put all known side and angle in this formula, and we can find a distance CB. Yes, this is A, and it will be 748.40 feet. Then you know all this equation, but we remember. Area of right triangle is base times here divided by 2. The area of an oblique triangle may be found if an equivalent base can be found that is perpendicular to an equivalent height by this formula. The area of an oblique triangle may also be found using this table, using all these relationships between sides and area and angle and area. Very easy. So the next circle. Why circle? Because many construction surveying problems in both building and highway construction involve curves, which may be all or a portion of a complete circle. A circle is a curved line that lies equidistant from a single point that lies at the center of the circle. So this distance is radius, and distance from intersect from one side to other that intersect the circle at 2 points and passes through the center is the diameter of the circle. Circumference of circle you can find by this equation. You know all this equation. Area of circle you can find on this equation. P multiple square diameter equals pi. This is the pi. Multiple square diameters divided by 4, and circumference equals pi multiple diameter, or 2 pi multiple radius. The length of the arc or related central angle, this is the central angle, can be found by ratio and proportion by this formula. This is very important formulas, and you can use in future like a surveyor all this formula. Also, you can find an area of segment. So this is a segment, and this is a sector. So area of sector you can find by this equation, and area of segment you can find by this equation. Area of segment is the area of a sector minus area of triangle formed by the chord and the two radius that bond the sector. Also here you can find a tangent. Tangent line intersects the circle at one point and is perpendicular to the radius at that point. Two tangents drawn from a single point outside the circle will have equal lengths and form equal angles between the tangent and the chord. A line from the single point to the center of circle will bisect the intercepted arc the chord and the central angle. Segment is the portion of the sector that lie between the chord and circle is a segment. The portion of the circle that lie within an inscribed arc is a sector. And the angle formed by the chord and the radius are inscribed angle. It was very important and useful formulas. Example: a subway tunnel is shaped as shown in figure, with a radius of 150 feet. What is the cross-sectional area of this tunnel? What is the cross-sectional area of this tunnel? So, very easy, yes? The area of shape you can find by noting that the shape is a circle with a segment removed. So area you can find like an area of circle minus area of segment. The chord that forms the base of the tunnel has a length equal to the radius of the circle. The triangle formed by the chord and two radius creates an equilateral triangle, and the central angle delta is 60 degrees. So area you can find by this formula, area of circle minus area of segment. Area of segment you can find by this formula. So pi to square radius, yes, square side, multiple to angle delta divided by 360 minus by formula 1/2 or 0.5 multiples to square chord that equal radius multiple to sinus 60 degrees. So area you already found. We have already found. The next one is also very useful and important for surveyors and may be very interested. And what is this? This is a rectangular coordinates, and surveyors typically references the location of a line to a coordinate axis in two-dimensional or x, y plane, xy plane that considers the positive y direction to represent north and the positive x direction to represent east. Coordinate pair are denoted as n, e rather than x, y, n, e, and refer to the location of a point by its north coordinate, northing coordinate also you can say, and its east coordinate, easting. A point located 100 units north and 100 north and 200 east. Units, yes, 100 units north and 200 units east of the origin will be denoted as has shown here. So construction drawing show dimensions related to the facility to be built. But during construction, surveyor must compute information not shown on the plans, such as the distance from known reference point to key points, such as building corners, location of underground utility, radius, points of curved line, also as computed lengths such as diagonal distance used for squaring up buildings. So surveyor must compute the required distance based on this example, NE coordinates assigned to a reference point. Rectangular coordinates are used to compute the direction and distance between points on a construction site. Distance we compute by this equation, and difference of northing and the difference of the easting define the altitude and base respectively of a right triangle. This process of finding the distance between 2 points using the rectangular coordinates called inversing the distance. And this distance you can find by this formula. And what is the E second? This is the east coordinate of the second point, and E first, this is the east coordinate of the first point of the pair of endpoints. N second is the north coordinate of the second point, and the N first is the north coordinate of the first point of the pair of end points. So distance of this line you can find by this formula. So example. How long is the length of the diagonal line AC of this figure if the coordinate of A is coordinates of A is next, and the coordinates of C are next. So C have coordinates, yes, so we find north coordinate, n second minus n first, and it will be 22 units, and east coordinate will be second east minus first east, and will be 42 units. And then we find all distance by this equation. It will be 47.41 units. The next very useful formula is to find the angle formed between a line and north. Angle between a line and north. So you can find of the angle formed by line either the x or east and also y by these formulas. This is very useful because surveyors reference the orientation of line to north, and this is why the angle formed between a line and north. Example, what is the direction with reference to north of the line formed by the line AC? If the coordinate the same that in last example, so using the equation, the angle formed by the y-axis north direction and the line AC found by second east coordinate minus first east coordinate divided by north second coordinate minus north first coordinate. So then you find a angle delta is 62 degrees 21 minutes and 14 seconds. So it was a very important topic, and you must understand that for a civil engineer there is no such thing as a little mistake. Thank you. Bye.